Okay, so here uh, is -3, this is negative 10%. So in the middle is 6.5. Okay, 6.5 negative 6.5 in the middle here. All right. Okay. In your example here, again, I've made a mistake by labeling this as 2%, negative 2%. This is actually negative 6.5, 6.5%. Okay, negative 6.5%. Sorry, okay, but I've made a mistake there. All right. So 7.5 at the right hand side, negative 6.5 left hand side. Okay, again, from your flat line here, positive 7.5% going up. It is just a few millimeters actually, so you need to be a bit careful. And the other side here is negative 6.5 going down. Okay, all right. So for the shoulder, the outer edge of your curve is 0.5%. So that the difference here is 8%. So you would go 1.5 meters for your shoulder going down. Since this is a cut section from your, this is a fill section, so this side applies from your typical cross section. So after your shoulder, you only have 0.5 meters, and then you have your slope. Okay, so 0.5 meters, you just continue with the same negative 0.5%. And then going down, you can use 10% here. And then go up 1.5 to 1, the ratio here. Okay, the same case on this side, 0.5 meters, and then go down 1.5 to 1, the slope. Alright, so since this is 6.5%, you can use the same value of negative 5% for your shoulder on this side. Okay, alright. Let's proceed with the last example of your cross section. So I have chosen KNH 80 here. Again, you draw a line with 5 points. You estimate the heights again of each point. Point number 3 you get from the vertical alignment here. So 80, again you estimate the height, change 80, what's here, what's the height over there on the y-axis, and your existing height is from your design line here, over here. So you estimate from the y-axis again. So you get the, or okay, if you don't want to use this, the more accurate way is to use this table lah. KNH 80 design height at 48.1. Okay, so you have 48.1 as your design height and 45 meters of your actual terrain height. Okay, let's mark on the graph. So I already marked a few points here, 1, 2, 3, 4, 5, and this is your design height. So this is straightforward lah. Okay, I also have marked 20 centimeters Close, and the middle is your center line, CL here. So this is 0, this is 5, 10, 15, and 20. Alright. Okay, so refer to your super elevation diagram at Chainish 80. Okay. At Chainish 80, you get the right hand side. Right hand side here is positive 2.5, and the left hand side here, it is on the straight line here, meaning that it is saya buat silap ni. This is positive, negative 3. Again, I made a mistake here. 1 minute. Okay, so on the left hand side is negative 3. So here, left hand side is negative 3%. Okay, so you have your right hand side at positive 2.5%, left hand side negative 3%. Again, I repeat, in your notes there, it's not 0%, it is negative 3%. Okay, alright, so we start with the flat guidelines here. One red line. Alright, your width of the road is 1.5 meters, somewhere here. On the left side is 1.5 meters, somewhere here. Okay, right hand side 2% going up. So you need to estimate again what is the angle. So I'm not going to, obviously I'm not going to measure accurately in this example. So this is positive 2.5 going up. Just use a pen. Positive 2.5 going up. So this is positive 2.5%. Left hand side negative 3% going down. So something like this. So this is negative 3%. Alright. Okay, shoulder, there's no issue here. You just continue using the normal gradient of the shoulder. So the width of the shoulder is 1.5 meters. You mark 1.5 meters. Another 1.5 meters here. Alright. So 5% going down, more or less. Here 5% going down. Alright, so you can see at Chainish 80 here, your cross section actually is a combination of fill and cut. Although the middle side here is fill, at the right edge and the left edge it is cut section. Okay, so you need to use this part. So you have another shoulder of 1.5 meters, and then you have another 1.5 meter of your verge. 1.5 meter. So 1.5 meters again. So over here. This side is over here. Alright. For the slope, okay, I don't mind. You just can use, you just estimate about 10%, 10% here, another 10% here. Alright. Next is just your slope going up, and here you just construct here going up. So this is 1.5 to 1, and here also is 1.5 to 1. meaning that 1.5 meters horizontal to 1 meter vertical. Okay, so you have cut section here and fill section here. So to differentiate your pavement area, you can draw another line here so that you can see that the actual pavement is over there. Okay, so there you have it, cross sections design for your example. Okay, so in real life we actually have to come up with all points. Okay, maybe every few meters we have another, maybe every 25 meters or 20 meters you have one cross section. So for your case you only have to do 10 cross sections. So the interval between the cross section is 10 meters lah. Alright, so I've shown you three scenarios. Okay, I've just thought of something. On top of that 10 cross section, can you add one more? Okay, add one more. You need to pick anywhere where the crossfall is normal, meaning that the road is straight. So in our case here, it is beyond this point 106.3 until the end of your chainage. Okay, so this is 106.3 at the end of the chainage. You can see here the crossfall is normal, 30%, negative 3% to the left and negative 3% to the right. So you add one more cross section where your road is on a straight. Okay, just to make sure that you know the normal crossfall for your road. Okay, all right, so I hope it is clear. Let's hope that you can get everything right lah. Okay, don't forget the deadline of the project here is, if I'm not mistaken, this is 15th of December, isn't it? Okay, never mind, we'll just discuss in class afterwards. Thank you.